Okie dokie, page number 4. So matching. Let's look at the standard form first. So standard form is a polynomial written from highest degree to lowest degree and all multiplied out. So that would be G. Factored form, that would be H. Y-intercept, right here. That would be K, which is 2. And then the point we were trying to make here with zeros and roots is that they are the same thing. So both A and D are x equals -2, 1/2, and 1. So yeah, both zeros and roots. Interchangeable, same thing. On to 12. All right, so this is day 3, and we are graphing. So let's fill in as much as we can before we go ahead and graph the polynomial. So first, degree. So we look at the highest exponent, and that's the degree. So the degree is 3. So that means that the maximum number of zeros is 3. So look at the leading coefficient. That would be 4. And type, third degree, that is a cubic function. So zeros, I'm going to wait on that constant term. That is 2. And that also means that my y-intercept is 2. So I'm going to go ahead and fill that in as well. All right. So if we look here, it's a positive even function. So that means that my end behavior using arrows is going to look something like that. End behavior using limit notation as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches negative infinity. Let's look at the maximum number of turns. So the max number of terms is always 1 less than the degree, so that would be 2. All right, so let's see what else can we fill out. All right, so let's go ahead and let's find some zeros. So I can't factor this, so let's go ahead and find the possible zeros, and then let's use synthetic division to find what an actual zero is. So when we look for our possible ones, again, it is my plus or minus, my factors of the constant term, which is P, over plus or minus the factors of Q. So we have there my factors of the constant term are 2, so I plus or minus 2 and 1, and then 4 times 1 times 2 times 2. So our possible zeros are going to be 1/2, 2, 1, 1/4, 1, and 1/2. So I don't need to repeat it. So those are my possible ones. So let's just go ahead and try 1. All right, so when we try 1, I'm going to extend this page a little bit. So I have 4, -5, -7, and 2. So 4, 4, -1, -1, -8, -8, negative, what did I do wrong? Nope, -8, so that would be -6. I have a remainder, so that is not a 0. So let's try a -1 then. So if I try -1, I have 4, -5, -7, and 2. So I have 4, -4, -9, +9, 2, -2, 0. So yay, the remainder is 0. That is a 0 to our problem. So now, factored form, I have 4x squared, not factored form, standard form, my polynomial left over, plus 2. So now let's see, can we factor this? So I'm going to use factor by grouping. I'm just going to multiply the first times the last. So I have 8x squared. So are there factors of 8x squared that I can add to give me negative 9x? Well, we have negative 8x times negative x. That adds to give me negative 9x. So I'm going to split that middle term. You could also use the quadratic formula. If you don't look at this and tell that it can factor, you'll still get the same solution. So that works as well, up to preference. So I'm going to group together two of them. I'm going to factor out my greatest common factor, which is 4x. So I've left x minus 2. And I'm going to factor out a negative 1 because I know I need to have my factor be x minus 2. That's x minus 2. So I have 4x minus 1 and x minus 2. So that means that my zeros are x equals 1/4, x equals 2, and then also synthetic division, my negative 1. All right, so now we can go back up and fill in the rest of our charts. Okay, so my zeros are x equals, then my 0, so 2, negative 1, and 1/4. So that means that my x-intercepts are 2, 0, negative 1, 0, and 1/4, 0. So are there any zeros of multiplicity greater than 1? No, because if you look at our function, there's a third degree. And so I have at max 3 zeros. I have 3 zeros listed, so I know that that is it. So, no. So let's go ahead and graph it, and then we can fill in the rest of our table. So let's think about the end behavior. So it's odd and it's positive. So I know my end behavior is going to be something like this. Okay, now my zeros, my x-intercepts. So all of these have a multiplicity of 1. So that means that they're all going to cross. So it's going to cross at negative 1. It's going to cross at 1/4. And it's going to cross at 2. My y-intercept is 2, so I know it has to cross there. So I'm just going to go ahead and connect. So it crosses at negative 1. My y-intercept crosses at 1/4, crosses at 2, and there I have my function. So my last few questions are the domain and the range. Well, actually, we could have filled this out beforehand. It's going to be negative infinity to positive infinity, as with the range and any other cubic function. So intervals in which, this last part, intervals in which f of x is greater than 0. So all that's saying, where is y greater than 0? So let's go back up to my function. I'm just going to go ahead and highlight where it's greater than 0. So it's greater than 0 right here. And it's greater than 0 here. So where is that? That's from negative 1 to 1/4 and 2 to infinity. Remember, we always write intervals in terms of x. So what did I say? I said negative 1 to 1/4, and they always get parentheses, and 2 to infinity. All right, that is the third page.